Hi friends, today we're going to be talking about reviewing fractions. So if you need to skip any of these parts, what I would suggest is go to all the way to the end of the video, and what I'll do is I'll have the timestamps for each of these so you can jump through to the ones that you need. All right, let's get started. All right, so we are going to talk now about reducing fractions. We're going to refresh this this skill set. Okay, so oftentimes when you were reducing fractions, you were told, find the greatest common factor, right? That is a great method. You can absolutely do that. However, I found this other method I call the 2, 3, 5, sometimes 7 method seems to work really well. So let's just talk about that really quick. It's basically the rules of divisibility. First one, 2. It ends in an even number. If something ends in an even number, then we know it is divisible by 2. And dividing by 2 just cuts something right in half. 3 is a really fun one. You add up the digits for a multiple of 3. And what I mean by that is, for example, if you had 3 plus 0 gives us 3, and that's a multiple of 3. So 3 is going to go into this number. For 36, 3 plus 6 would give us 9, and 3 is a multiple of 9, so 3 is going to go into this number. Another one might be like 42. 4 plus 2 is 6, which is a multiple of 3, so 3 is going to go into 42. So that's how you tell on the 3s. Now 5s, it ends in a 5 or a 0. And also, friends, if you have not yet grabbed your notebook, you're going to want to be writing these things down because these notes are going to be helpful. So make sure you're doing that, especially these things. For 7s, honestly, I don't know. You're going to have to learn your 7s. Learn your multiplications tables for 7s. Okay, so let's talk about reducing. First things first, I always look at my 2s, and if I have an even number, like I do for number 1, 30 and 36, all I do is cut those guys in half. And if I do, I get 15, and half of 30 is 15, half of 6 is 3, which means half of 36 is 18. Okay, I look at that again, and I can't cut those in half again. So I try my 3 method. And if I add up 1 plus 5, I get 6. And if I add up 1 plus 8, I get 9. Both 6 and 9 are multiples of 3, so I'm going to divide these guys by 3, and I get 5 over 6. I almost wrote 9. Jeez, with the math. All right. For number 2 here, you'll see we have 70 over 80. Yes, both 70 and 80 are even, and I can cut them in half. However, this is a really fun one. All you got to do is lob those zeros off, and you're left with 7 over 8. Now, that only works for zeros. Don't be coming for me if you're trying this with your 2s or your 5s. It only works for zeros because essentially what we're doing is dividing by 10. 70 divided by 10 is 7. 80 divided by 8 is 8. Or 80 divided by 10 is 8. All right, so 35 over 50. I can't do my 2s because 35 is not even. I can't do my 3s because 5 plus 3 is 8, and that's not a multiple of 3. So what I gotta do is divide by 5 because they both end in either a 0 or a 5. If I do that, I end up with 7 over 10. All right, that's for reducing fractions. Moving on to the next one. All right, so our next refresh is mixed numbers to improper fractions. So this is a mixed number. And just as a reminder, a fraction in general is usually our part over our whole. And sometimes we have a whole lot more than our whole here. We have 4 wholes, and then we have 3/4, which is our part over our whole. So turning this mixed number into an improper fraction, here's what you do. You take, and again, you should be writing this in your notebook, 4 times 4, which gives us 16. So we multiply those two, then we add 3. So 16, 17, 18, 19, we get 19. Our denominator, which is the bottom one, always stays the same. All right, let's try that again. 6 times 2 is 12. Plus 5 is going to give me 17. So I got 17 over 6. That is how you turn mixed numbers into improper fractions. All right, friends, now let's do the reverse. So we're going from improper fraction to mixed number. Best way to do this is, you see 3 is on top of the table here. We're going to put it under our table when we divide. What we're going to do is do 5 into 30 6 times. 5 into 33, 6 times. We want to go into 33 without going over. 6 times 5 is 30. Subtract, and that gives us a remainder of 3. And so we put 3 over whatever our denominator is here. So 6 3/5. All right, 89 over 8, same thing. 89 is on top of the table. Let's go ahead and put it under the table here. Now we do 8 goes into 8 one time. 1 times 8 is 8. Subtract, and we get 0, and bring down and when we subtract, we bring down. 8 goes into 9 one time, 8, and we have a remainder of 1, so we take that 1 and we put it over our denominator of 8. That is how you put an improper fraction into a mixed number. All right, folks, we're going to do a quick refresh on adding fractions. Now, when we are adding fractions, we need our denominators to be the same. It's called common denominator. Okay, so on this case, we have 3 14s plus 5 14s. We end up with 8 14s. Okay, but what happens when we don't have a common denominator? Look at number 2 here. And again, make sure you're writing this in your notebook. We have a 3 and we have a 5 here. What we have to do is find our common denominator. You can use a multiplication chart to look at 3s, and then we look at our 5s. And if you look at those guys, you will see that we have 15 in common. That's because we can multiply 3 times 5 to get 15. Now, you can't always just multiply the bottom 2 numbers to get your common denominator. It will give you a common denominator, but you're going to want your least common denominator unless you want to have to reduce. And what I mean by that is, if I did 6 and 8, if I multiply those together, I would get 48, right? But then let's take a look at our chart here. We've got 6, and I'll highlight those guys, and then we have 8, and you'll find that the smallest number that they have in common here is 24, not 48, okay? So be very careful about that unless you want to have to reduce at the end. Okay, so for 3 and 5, we're just going to multiply them by each other. 15 is going to be our common denominator. If I multiply the bottom, I have to multiply the top. If I multiply the bottom, I've got to multiply the top. So let's go ahead and rewrite that fraction. We have 5 over 15 plus, because 5 times 5 times 3, plus 6 over 15. 15 equals, so we have 5 15s plus 6 15s. We now have 11 15s. Okay, now let's talk about when it's a mixed number. Now you can put these into an improper fraction. So 4 times 1 is 4 plus 1 is 5. So 5 over 4 plus 2 times 2 is 4 plus 1 more is 5. So we get 5 over 2. But again, we have to have a common denominator when we're adding and subtracting fractions. Our common denominator in this case, this is a case again where we don't want to multiply them by each other because that would give us 8. And our common denominator is actually just 4. So multiply this by 2, this by 2. Okay, so I end up with 5 over 4 plus 10 over 4, which gives me 15 over 4. I didn't leave myself enough room there. Sorry about that. So 5 over 4 plus 10 over 4 gives me 15 over 4. Now, you can leave that in an improper fraction form. That's totally fine. In fact, as you go on in algebra, you're probably going to be using improper fractions, unless you have to graph something, because then you want to put it in a mixed number so you know where to graph it. And you can also add while they are in mixed number forms. So like in this case, if you didn't know what 5 times 13 was and you didn't want to do all the side work, what we can do is deal with just the fraction bits here. So that's 3 over 5, and that's 1 over 8, and I'm sorry that that's kind of tiny there. Okay, so 8 and 5 is going to be, our least common denominator is 40. So multiply this by 5, and this by 5, this by 8, and this by 8. To make it a little bit easier for you to read, I'm going to switch into a different color so you can see here. Okay, so what I have now is 13, and 8 times 3 is 24, over 8 times 5, which will give me 40, plus 2, 1 times 5 is 5 over 40, which gives me then 24 plus 5, 24 40th plus 5 40th gives me 29 40ths. Now I can add the whole numbers. 13 plus 2 is going to give me 15. So my final answer, 15 29 40ths. Okay, now again, see, this would be a good case where you don't want to have to turn it into an improper fraction, because 72 times 2, and then, that's terrible. So let's deal with the fraction bits first. I've got a denominator of 4 and 2. And again, my common denominator is going to be 4. So I have 2 over 4 and 3 over 4. I'm adding those together. So that is going to give me 5 over 4. 5 over 4. Now, that is an improper fraction, right? So what we have to do, a little side work here, 5 over 4. 4 goes into 5 one time with a remainder of 1. So 5 over 4 is really 1 and 1/4. Now let's deal with this, the whole numbers here. 5, 6, 7, so I would have 7 here. 7 plus 3 is 10, so I'd have 107. 107 plus this guy over here gives me 108 and 1/4 for my final answer. So that's another way of doing it. All right, thank you. Okay, so let's talk about subtraction now. I'm going to leave these in mixed numbers just so you can see, but you can always turn them into improper fractions and subtract that way. I'm going to deal with my fraction bits first here, and you see I have an 8 and a 5, and again, that's going to be 40 for our common denominator. So multiply by 5, multiply by 8, multiply by 8. Again, whenever I do on the bottom, I have to do to the top. So I end up with 24 over 40 and 5 over 40, which gives me, now remember we are subtracting here. So 24, and I like to cross that out. 24 minus 5 is going to give me 19 over 40. 19 over 40. 13 minus 2 is going to give me 11. Sometimes it doesn't always work out that way, and you have to do a little bit of borrowing. So again, 8 and 5 here. I'm sorry I chose the same ones for our common denominator, but let's take a look at this. If we go ahead and do this, we end up with 24 over 40 and 35 over 40. Now, if I go to subtract 24 minus 35, I'm going to get a negative number, and so I can't do that. So this is where you have to borrow. Here's how you borrow. You take 1 away from this, so this becomes 12. Whatever this bottom one is, you add to this here. So what we have now is 12 and 64 40ths minus 2 and 35 over 40. All right, so let's double check on our calculators. We've got 64 minus 35, and I say that because I don't want to make a small arithmetic error on these videos. So we get 29 out of 40, and 12 minus 2 would give us 10. So that is how you subtract when you need to borrow. Again, you can put these into improper fraction form, and then you wouldn't have to do the borrowing bit, but I wanted you to be aware of how that works. All right, friends, let's go on to multiplication, because multiplication, you do not have to have a common denominator. Way easier, way easier. So when we multiply straight across the top, straight across the bottom. 35 over 27, kablam, that's it, you're done. You do always want to double check, can I reduce that? No, we are good to go. So, excellent. Now, let's talk about number 2 here. If you have a whole number and you're multiplying it by a fraction here, what you can do is set it up like this. So I have 12 over here, and I'm multiplying by 2 and 3/4. So I split those up. So this is going to be 24. I'm multiplying 12 times 2 to get 24. Now I want to multiply 12 times 3/4. Let's do a little side work. 12 over 1 times 3 over 4. That gives me 36 over 4, which reduces down to 9. Okay, once you have those both filled in, all you have to do is add them. So 24 plus 9 is going to give me 33. So that's kind of a neat way to do it if you don't want to have to turn it into a mixed number, or I'm sorry, into an improper fraction. Okay, but in this case, I went out of order on these, so my apologies. What I do want you, though, to be familiar with is reducing your fractions before you actually do the multiplication. This is called cross-canceling. Don't get it confused with cross-multiplying. Cross-multiplying is when there's an equal sign in the middle. This is where we're just multiplying flat out. And what it is, I'll show you the longer way of doing this. 5 times 3 over 12. And let's go ahead and write 12 as 3 times 4. And 10 we're going to write as 2 times 5. And the reason I do that is because now I can cancel out a 5 and I can cancel out a 3, which leaves me with, and if you cancel everything out of the top, your numerator, remember it's not a 0, it's a 1. So what I have is 1 over 8. Now you're going to want to get quick at this, and so the way it would look as you get quicker is, oh, I see something that has a common. So divide by 5, I get 1. Divide by 5, I get 2. Divide by 3, I get 1. Divide by 3, I get 4. and multiply straight across the top, I get 1. Straight across the bottom, I get 8. So you see how that kind of works. Again, that's called cross-canceling, not cross-multiplying. Okay, or you could turn them into improper fractions. So 9 times 1 is 9 plus 1 more is 10. 10 over 9 times 5 times 2 is 10 plus 2 is 12. So 12 over 5. I now see an opportunity for me to cross-cancel. I can say divide by 5, I get 1. Divide by 5, I get 2. Divide by 3, I get 9. Divide by 3, I get 4. Multiply straight across the top, I get 2 times 4 is 8. And straight across the bottom, 3 times 1 is 3. Now, if you did not cross-cancel before you went ahead and you just multiplied straight across the top, straight across the bottom, that's fine, but you're going to have to reduce your fractions at the end. So it's a good idea to go ahead and cross-cancel. Okay, so now it's time for us to talk about division. And here's the neat thing. We never divide fractions. What we do instead is we multiply by the reciprocal. I hope I spelled that right. I always mess that word up. Okay, so we don't divide by any fractions. We never divide fractions. We multiply by the reciprocal. You may have heard it as keep, change, flip. That's another familiar one. What that means is when we have a division problem, we say 5 divided by 7, and then we multiply instead, and the reciprocal of a number is just flipping it around. So this is going to be 5 over 4. Multiply straight across the top. We want to look first to see can we cancel anything out? Nope. So we get 25 over 28. Okay, and just a quick note on the reciprocal. Something like the reciprocal of 3. Remember, we can turn anything into a fraction by putting it over 1. So the reciprocal would be 1 over 3. Same if you had like 1/7. Our reciprocal then would be 7. That's it. 7 over 1 if you need to. Now, sometimes you might see a division problem like this. Remember, fractions just mean division. So this is what we call a complex fraction. And what you can do is you can either write it out as a division problem, 8 over 21 divided by 16 over 27, or you can multiply by the reciprocal, 27 over 16. Because when I do that, this cancels this cancels this cancels this, and I get rid of it. But if I do it on the bottom, I have to do that on the top. So we get 27 over 16. And now, again, I see an opportunity for me to cross-cancel here. I've got 8 and 16. So if I divide by 8, I get 1. Divide by 8, I get 2. Over here, it looks like I've got a 3 in common. Divide by 3, I get 7. Divide by 3, I get 9. So what we have now is 1 times 9 and 7 times 2. So we get 9/14. All right, thank you for joining me. If you have any questions, let your teacher know. Otherwise, we'll see you next time. All right, so this is the timestamp for all of these different subjects, just in case you need to jump around to look at each one of those. All right, we'll see you next time, folks.